Imagine a nebula carved from the dying breath of a star, its tendrils forming the sinewy mane of a celestial lion, eyes glowing with the ghostly light of elements forged in stellar furnaces. This is the hauntingly beautiful image captured by the James Webb Space Telescope, where a dying star's final act of creation sculpted a cosmic predator from its own remnants. The lion's body, a swirling tapestry of gas and dust, is not just a spectacle but a testament to the violent beauty of stellar evolution. At its heart, the star's fading glow ignites the surrounding material, forging heavier elements in a final dance of fusion before collapse. This isn't just a picture, it's a story etched in light, a reminder that even in destruction, the universe crafts wonders. What secrets lie hidden in the lion's gaze? How did this sculpture form? And why does it feel almost alive? In the vast expanse of space, where stars are born and die in cosmic dramas spanning millions of years, the James Webb Space Telescope has unveiled a breathtaking spectacle, a nebula shaped like a lion, sculpted by the final breaths of a dying star. This isn't just a stunning image, it's a window into the life cycle of stars, revealing how the end of one celestial body can create beauty that outlives it. The discovery, captured by the JWST, offers a glimpse into the processes that govern the universe, blending art and science in a way that feels almost poetic. Let's explore what this cosmic lion means and how it fits into the grand story of stellar evolution. Stars, like the Sun, live for billions of years, but their lives don't end in quiet fade-outs. When a star like our Sun reaches the end of its life, it begins to shed its outer layers, creating a glowing shell of gas and dust. This process, known as a planetary nebula, is one of the most dramatic and beautiful phases in a star's life. The JWST's image of the cosmic lion is a striking example of this phenomenon. The nebula, which resembles a lion's form, is the result of a star that has expelled its outer layers, leaving behind a glowing shell that stretches across space. The lion's mane, eyes, and other features are not literal, but rather the result of complex interactions between the star's outflows and the surrounding interstellar material. To understand how this cosmic lion came to be, we need to look at the life cycle of stars. Most stars, including our Sun, begin their lives as massive clouds of gas and dust, collapsing under gravity to form dense cores. Over millions of years, these cores ignite nuclear fusion, converting hydrogen into helium and releasing energy that keeps the star stable. This phase, known as the main sequence, can last for billions of years. However, once a star exhausts its hydrogen fuel, it begins to evolve. For stars like our Sun, this means expanding into a red giant, a swollen, luminous star that can engulf its surrounding planets. As the red giant evolves, it begins to shed its outer layers, creating a glowing shell of gas and dust, a planetary nebula. The JWST's image of the cosmic lion captures this process in exquisite detail. The nebula's structure is not random, it is shaped by the star's outflows and the surrounding interstellar medium. The lion's mane is composed of dense, glowing filaments of gas, while its eyes are regions of higher density where the ejected material has clumped. These features are not static, they are the result of dynamic interactions between the star's wind and the surrounding material. The colors in the image, which range from deep reds to vibrant blues and greens, are caused by different elements glowing at specific wavelengths. Oxygen emits red light, while ionized nitrogen and sulfur produce blue and green hues, creating the rich tapestry of colors that make the nebula so visually striking. The star at the heart of this nebula is no longer visible as a bright, luminous object. Instead, it has shrunk to a dense, hot core known as a white dwarf. This remnant of the star's former self is no longer undergoing fusion, but it still radiates energy, influencing the surrounding nebula. The white dwarf's gravitational pull and magnetic field can shape the outflowing gas, creating intricate patterns that we see in the nebula's structure. The JWST's ability to capture these details is a testament to the power of modern astronomy. Unlike earlier telescopes, which struggled to see through the dense clouds of dust and gas, the JWST's infrared sensors can peer through these obstacles, revealing the hidden processes at work. The discovery of this cosmic lion is more than just a marvel of photography, it is a critical piece of the puzzle in understanding how stars evolve and how elements are distributed throughout the universe. When a star sheds its outer layers, it releases heavy elements like carbon, oxygen, and nitrogen into space. These elements are the building blocks for future generations of stars and planets, including the Earth. The nebula's glow is not just a visual spectacle, it is a reminder of the interconnectedness of all matter in the universe. The same elements that make up our bodies and the planets we inhabit were forged in the hearts of stars that died billions of years ago. The cosmic lion is a symbol of this cosmic recycling, a reminder that even in death, stars leave behind a legacy that shapes the universe. The JWST's ability to capture such detailed images is a result of its advanced technology and its position in space. Launched in 2021, the telescope orbits the Sun at a distance far beyond the Moon, allowing it to avoid the interference of Earth's atmosphere. Its infrared sensors are designed to detect light that has been stretched by the expansion of the universe, making it possible to study distant objects that would be invisible to other telescopes. The cosmic lion is one of many such discoveries that the JWST has made possible, offering a new perspective on the universe's history and its ongoing evolution. By studying these nebulae, astronomers can trace the life cycles of stars, understand how elements are distributed, and even gain insights into the formation of galaxies. The significance of the cosmic lion extends beyond its aesthetic appeal. It provides valuable data for scientists studying stellar evolution and the processes that govern the universe. Each nebula is a unique snapshot of a star's final days, offering clues about the star's mass, composition, and the environment in which it formed. By analyzing the structure of the nebula, astronomers can infer the star's history and predict how similar stars will evolve in the future. The JWST's high-resolution images allow for precise measurements of these features, contributing to a deeper understanding of the universe's dynamics. In the broader context of astronomy, the discovery of the cosmic lion highlights the importance of long-term observation and technological advancement. The study of stellar life cycles has been a cornerstone of astronomy for centuries, but the JWST's capabilities have opened new avenues of research. By capturing images of nebulae in unprecedented detail, the telescope is helping scientists refine their models of star formation, evolution, and death. These models are essential for understanding not only the fate of individual stars but also the overall structure and history of the universe. The cosmic lion is a reminder that even in the vast emptiness of space, there is a story to be told, one that is both beautiful and scientifically profound. As we look at the cosmic lion and its intricate details, we are reminded of the incredible scale and complexity of the universe. The image is a testament to the power of human curiosity and the ingenuity of modern science. It is a reminder that the universe is not just a collection of distant stars and planets, but a dynamic, ever-changing system where the processes of creation and destruction are intertwined. The JWST's discovery of this nebula is not just a moment of awe, it is a step forward in our quest to understand the cosmos. By studying such phenomena, we gain insights into the fundamental forces that shape the universe and the role that stars play in its ongoing story. The cosmic lion is more than a beautiful image, it is a symbol of the enduring connection between the stars and the life that exists within them. James Webb captures a cosmic lion sculpted by a dying star. This part of our deep dive into James Webb captures a cosmic lion sculpted by a dying star focuses on walk through how scientists found or confirmed this instruments, telescopes, missions, method, timeline. Make the process itself feel impressive. Scientists are still cross-checking the data before drawing firm conclusions, which is exactly the kind of patience that makes space science trustworthy. None of this comes from speculation, it comes from instruments built to measure faint signals that the naked eye could never pick up on its own. It's easy to forget how much coordination sits behind a single headline like this: years of engineering, calibration, and review before anyone announces anything. That's part of why stories like this take time to fully confirm. Good science moves carefully, even when the early results already look remarkable. For viewers who want to go deeper than this summary, the primary source linked in the description lays out the full technical picture. Findings like this rarely stand alone, they get compared against earlier observations to make sure the pattern holds up under scrutiny. Scientists are still cross-checking the data before drawing firm conclusions, which is exactly the kind of patience that makes space science trustworthy. None of this comes from speculation, it comes from instruments built to measure faint signals that the naked eye could never pick up on its own. It's easy to forget how much coordination sits behind a single headline like this: years of engineering, calibration, and review before anyone announces anything. That's part of why stories like this take time to fully confirm. Good science moves carefully, even when the early results already look remarkable. The image captured by the James Webb Space Telescope is more than just a stunning visual, it's a window into the final chapter of a star's life. At first glance, the swirling, luminous patterns resemble the majestic mane of a lion, but this is no mere artistic coincidence. This is a planetary nebula, a celestial phenomenon born from the death of a star. To understand why this image is significant, we need to look beyond its beauty and delve into the physics of stellar evolution. When a star like our Sun reaches the end of its life, it undergoes a dramatic transformation. After exhausting its nuclear fuel, the star expands into a red giant, its outer layers cooling and shedding into space. What remains is a dense, glowing core, what we call a white dwarf, surrounded by the expelled material. This material, once part of the star, is now scattered into space, forming a glowing shell known as a planetary nebula. The intricate patterns we see in this image are the result of this process, shaped by the star's final moments. But why does this matter? Because planetary nebulae are not just remnants of dying stars, they are cosmic recycling centers. The material ejected during this phase contains elements forged in the star's heart, from carbon and oxygen to heavier elements like iron. These elements become the building blocks for new stars, planets, and even life. By studying these nebulae, astronomers can trace the history of element creation in the universe, revealing how stars have shaped the cosmos over billions of years. The James Webb Telescope's ability to peer into these distant structures is a testament to human ingenuity. Its advanced infrared sensors allow it to see through the dust that often obscures such nebulae, revealing details that were previously hidden. This image, with its lion-like form, is a prime example of how technology enables us to witness the universe's most dramatic events. But the significance of this observation goes deeper. The structure of a planetary nebula can tell us about the star that created it. The way the gas is distributed, the presence of certain elements, and the symmetry or asymmetry of the nebula all provide clues about the star's mass, its environment, and even its interactions with other celestial bodies. For instance, some planetary nebulae exhibit complex shapes, like the lion's mane in this image, which may be influenced by magnetic fields, stellar winds, or even the presence of a binary companion star. These details are not just aesthetic, they are vital for understanding the physics of stellar death and the processes that govern the life cycle of stars. Moreover, planetary nebulae play a crucial role in the chemical evolution of galaxies. As stars shed their outer layers, they enrich the interstellar medium with heavy elements, which can then form new stars and planetary systems. This cycle of creation and destruction is fundamental to the universe's ability to sustain life. The materials that once formed the lion's mane in this image may one day become part of a new Earth, a new star, or even a future civilization. This underscores the interconnectedness of all cosmic phenomena. The James Webb Telescope's ability to capture such intricate details is not just a technical achievement, it's a milestone in our quest to understand the universe. By studying these nebulae, scientists can refine models of stellar evolution, test theories about element distribution, and gain insights into the conditions that led to the formation of our own solar system. The image of the cosmic lion is a reminder that the universe is not just a collection of distant stars and galaxies, it's a dynamic, ever-changing system where the life and death of stars shape the very fabric of existence. Yet, the significance of this observation extends beyond the immediate scientific implications. It also serves as a powerful metaphor for the cycle of creation and renewal that defines the cosmos. Just as a lion's mane is a symbol of strength and vitality, the glowing nebula represents the enduring legacy of a star's life. In a way, this image captures the essence of stardust, how the elements that make up our bodies, our planets, and even the stars themselves were forged in the hearts of ancient stars. The James Webb Telescope's ability to reveal such details is a testament to our capacity to look beyond the surface and uncover the profound connections that bind the universe together. As we continue to explore these distant realms, each new image brings us closer to understanding our place in the cosmos. The cosmic lion, with its intricate patterns and luminous form, is more than a scientific curiosity, it's a symbol of the universe's enduring mystery and the infinite possibilities that lie within the vast expanse of space. For decades, our understanding of the cosmos has been shaped by the relentless pursuit of light, both visible and invisible. The journey to uncover the secrets of stars and their life cycles began long before the James Webb Space Telescope captured its latest marvel. It started with the earliest space missions, which laid the groundwork for the sophisticated instruments we now rely on. In the 1960s and 1970s, radio telescopes became the first tools to peer into the dark, revealing the vast molecular clouds where stars are born. These observations hinted at the chaotic dance of gas and dust, but they lacked the resolution to see the intricate details of stellar nurseries or the dramatic endings of stars. The 1980s and 1990s marked a turning point with the launch of the Hubble Space Telescope, which brought unprecedented clarity to the visible universe. Hubble's images of nebulae like the Orion Nebula revealed young stars forming within glowing clouds of gas, but even its advanced optics had limits. Dust and cosmic debris obscured much of what lay beyond, especially in the infrared spectrum, a wavelength critical for studying the birth and death of stars. This gap in our ability to observe the universe in infrared light became a driving force for the next generation of telescopes. The 1990s and 2000s saw the rise of infrared astronomy, with missions like the Spitzer Space Telescope taking the first major steps. Spitzer, launched in 2003, operated in the infrared range and provided groundbreaking insights into star-forming regions, supernova remnants, and the structure of distant galaxies. Its ability to detect the heat signatures of young stars and dying stars opened new windows into the universe, but its resolution was still limited by the technology of the time. Scientists realized that to truly grasp the full story of stellar evolution, they needed a telescope with far greater sensitivity and resolution in the infrared. This led to the conceptualization of the James Webb Space Telescope, a project that spanned decades of planning and innovation. Unlike Hubble, which orbits Earth, Webb was designed to be placed in a stable orbit far from our planet's thermal interference, allowing it to capture the faintest signals from the cosmos. Its primary mirror, 6 times larger than Hubble's, and its advanced instruments were engineered to peer through the dust that had long hidden the secrets of star formation and stellar death. The development of Webb was not just a technological leap, it was a culmination of decades of scientific curiosity and the recognition that the universe's most dramatic processes, from the birth of stars to their violent endings, often occur in regions shrouded in darkness. As the decades passed, the field of astronomy evolved from fragmented observations to a more integrated approach, combining data from radio, optical, and infrared telescopes. Each mission built on the last, refining our ability to see deeper into the cosmos. The discovery of the cosmic lion sculpted by a dying star is not an isolated moment but the result of this long, collaborative journey. It is a testament to how far we've come and how much further we have to go in unraveling the universe's mysteries. The image of the cosmic lion, captured by the James Webb Space Telescope, is more than a stunning visual spectacle, it's a window into the chaotic and creative processes of the universe. At first glance, the nebula's sinuous, lion-like form seems almost artistic, but beneath its striking appearance lies a complex interplay of physics and stellar evolution. This structure is the result of a dying star's final act, a massive star in its final stages of life, shedding material into space through stellar winds and radiation. These outflows sculpt the surrounding gas and dust, carving out intricate shapes that can resemble animals, galaxies, or even abstract patterns. The lion's form, however, raises intriguing questions. How did the star's outflows create such a specific, almost lifelike structure? What forces shape the nebula's contours, and how do they compare to other stellar phenomena? These mysteries are at the heart of the scientific debate surrounding this discovery, and they reveal the limits of our current understanding of stellar death and cosmic sculpting. One of the most pressing questions is the nature of the dying star itself. Was it a red giant, a Wolf-Rayet star, or some other type of evolved star? Each of these possibilities would imply different mechanisms for shaping the nebula. A red giant, for example, expels its outer layers in a slow, steady wind, while a Wolf-Rayet star, a massive, hot star with strong stellar winds, could create more dramatic, high-velocity outflows. The lion's form suggests a balance between these forces, but the exact processes remain unclear. Scientists are also debating whether the star's outflows were continuous or episodic. Did the nebula form over thousands of years, or did it develop in sudden bursts of material ejection? High-resolution images from JWST are helping to address these questions, but the data is still incomplete. For instance, the telescope's infrared capabilities reveal details about the composition of the nebula's gas and dust, but they cannot yet capture the full dynamics of the star's final moments. Without direct observations of the star's behavior, researchers must rely on indirect evidence, which leaves room for multiple interpretations. Another unresolved issue is the nebula's age and its relationship to the star's life cycle. How long has this structure been evolving, and what does its current state tell us about the star's final stages? Some scientists suggest that the lion's form is a relatively recent creation, shaped by the star's final outbursts. Others argue that the nebula may have formed over millions of years, with the star's outflows gradually carving its shape. This debate is crucial because it affects how we model stellar evolution. If the nebula is young, it could indicate that the star's death was sudden and energetic, like a supernova. If it's old, it might suggest a slower, more gradual process. However, determining the nebula's age is complicated by the fact that we can only observe its current state. The light we see from the star and its surroundings has traveled vast distances, meaning we're seeing a snapshot of a process that may have already changed. This temporal ambiguity adds another layer of mystery to the discovery. The lion's form also raises questions about the role of magnetic fields in shaping the nebula. Some theories suggest that magnetic fields could guide the outflows of material, creating the intricate patterns observed in the image. However, the extent to which magnetic fields influenced the nebula's structure is still debated. While JWST's data provides clues about the composition and distribution of gas and dust, it doesn't directly measure magnetic fields. This means that researchers must infer their presence based on other observations, such as the alignment of particles or the behavior of ionized gas. The possibility of magnetic fields shaping the nebula adds another dimension to the mystery, but it also highlights the limitations of our current tools. Without a dedicated instrument to measure magnetic fields in space, scientists can only speculate about their role in the nebula's formation. Beyond the nebula itself, the discovery of the cosmic lion has sparked broader discussions about the diversity of stellar death. While supernovae and planetary nebulae are well-known phenomena, the lion's structure suggests that there are other, less understood ways in which stars can end their lives. This raises the question, are there other undiscovered types of stellar remnants or nebulae that we haven't yet observed? The JWST's ability to peer into the infrared spectrum has already revealed new classes of objects, and the lion's image may be just the beginning. However, the telescope's observations are still limited by factors such as resolution, field of view, and the brightness of the objects being studied. For example, while JWST can capture detailed images of nearby nebulae, it may struggle to observe similar structures in more distant regions of the universe. This means that the lion's form could be an exceptional case, or it could be part of a larger, yet unrecognized pattern in the cosmos. The scientific community is also grappling with the implications of the lion's discovery for our understanding of star formation and the life cycles of stars. If a dying star can create such a complex and visually striking structure, what does that mean for the environments in which stars are born? Some researchers propose that the processes shaping the lion's nebula could be analogous to the mechanisms that form protostars in molecular clouds. Both involve the interaction of gas, radiation, and magnetic fields, but the scales and timescales are vastly different. This connection suggests that the same physical principles may govern both the birth and death of stars, but the exact relationships remain unclear. Studying the Lion's Nebula could therefore provide insights into the broader processes of stellar evolution, bridging the gap between the early and late stages of a star's life. Despite the excitement surrounding the Lion's discovery, there are still many unanswered questions that scientists are actively working to solve. For instance, the exact composition of the nebula's gas and dust is still being analyzed, and different elements may have different implications for the star's history. Some studies suggest that the presence of certain heavy elements could indicate that the star had already undergone multiple generations of nuclear fusion, while others argue that the composition is more consistent with a single, massive star. These findings could reshape our understanding of how stars evolve and how they contribute to the chemical enrichment of the universe. However, without more data, these interpretations remain tentative. The JWST's observations are providing new insights, but they are also revealing the complexity of the systems we're studying. Ultimately, the cosmic lion is a reminder of how much we still have to learn about the universe. While the James Webb Space Telescope has given us a glimpse into the final moments of a dying star, it has also highlighted the vastness of the unknown. The lion's form is a testament to the beauty and complexity of cosmic processes, but it also underscores the challenges of interpreting such phenomena. As scientists continue to analyze the data from JWST and other observatories, they will undoubtedly uncover new details about the nebula's origins and the star's life cycle. However, the questions raised by the Lion's discovery are likely to persist, driving future research and deepening our appreciation for the mysteries of the cosmos. In the end, the Lion's image is not just a snapshot of a dying star, it's a call to explore the unknown, to seek answers, and to marvel at the universe's ability to create such wonders. James Webb captures a cosmic lion sculpted by a dying star. This part of our deep dive into James Webb captures a cosmic lion sculpted by a dying star focuses on explain what's coming next, future missions, instruments, or observations that could confirm, extend, or challenge what we know so far. Scientists are still cross-checking the data before drawing firm conclusions, which is exactly the kind of patience that makes space science trustworthy. None of this comes from speculation, it comes from instruments built to measure faint signals that the naked eye could never pick up on its own. It's easy to forget how much coordination sits behind a single headline like this: years of engineering, calibration, and review before anyone announces anything. That's part of why stories like this take time to fully confirm. Good science moves carefully, even when the early results already look remarkable. For viewers who want to go deeper than this summary, the primary source linked in the description lays out the full technical picture. Findings like this rarely stand alone, they get compared against earlier observations to make sure the pattern holds up under scrutiny. Scientists are still cross-checking the data before drawing firm conclusions, which is exactly the kind of patience that makes space science trustworthy. None of this comes from speculation, it comes from instruments built to measure faint signals that the naked eye could never pick up on its own. It's easy to forget how much coordination sits behind a single headline like this: years of engineering, calibration, and review before anyone announces anything. That's part of why stories like this take time to fully confirm. Good science moves carefully, even when the early results already look remarkable. So, what did we just witness? The James Webb Space Telescope has unveiled a cosmic lion, a nebula shaped like a majestic predator, sculpted by the final breaths of a dying star. This isn't just a pretty picture, it's a vivid snapshot of stellar evolution, where the end of one star's life births something breathtakingly intricate. The lion's form is no accident. It's the result of a red supergiant star, nearing its death, expelling layers of gas and dust into space. These outflows, driven by the star's intense radiation and pulsar winds, carve the surrounding material into the lion's mane, its eyes, and the shadowed regions of its body. It's a dance of destruction and creation, a reminder that even in the universe's most violent processes, beauty emerges. But here's the kicker: this nebula isn't just a static sculpture. It's a dynamic, evolving system. The star's remnants, its core, perhaps a neutron star or black hole, continue to influence the surrounding gas, shaping the nebula's structure over millennia. JWST's infrared vision pierces through the dust, revealing details we've never seen before. This image isn't just about the lion, it's about the star's legacy. Every glowing filament, every dark silhouette, tells a story of how stars seed the cosmos with the ingredients for new stars, planets, and life. And yet, this discovery isn't just about the lion itself. It's a testament to JWST's power. Before this telescope, such intricate details were hidden behind cosmic fog. Now, we're seeing the universe in unprecedented clarity, uncovering secrets that challenge our understanding of stellar death and rebirth. But here's the question: what other cosmic sculptures are waiting to be discovered? What other stories are hidden in the dust? That's why we're here, chasing the unknown, piece by piece. If you enjoyed this deep dive, hit subscribe for more space mysteries, and don't forget to drop your theories or questions in the comments. After all, the universe is full of lions, and we're just beginning to see them.